Alright everyone, let's go ahead and get started. Example 1. Jeff makes money fixing mobile device screens. It takes him an average of 30 minutes to fix a phone screen and 45 minutes to fix a tablet screen. He charges $10 for each cell phone and $15 for each tablet. James has no more than 6 hours available each weekend to fix phones and tablet screens. He wants at least 10 screen fixing jobs each weekend. And then we have a list of instructions that we want to complete here. So, as always, first thing we want to do is we want to underline the important information. Make this a little smaller. So Jeff makes money fixing mobile device screens. It takes him an average of 30 minutes to fix a phone screen and 45 minutes to fix a tablet screen. He charges $10 for a cell phone, $15 for a tablet, has no more than 6 hours available each weekend. He wants to work at least 10 screen fixing jobs. Now, this is just important information that I thought. You might have something different, and it also doesn't mean that we're going to use every single piece of information. Okay? So first thing it says is define variables right here. So let's go ahead and do that. How about, since we're talking about phones and we're talking about tablets, let's do something like P equals phones and T equals tablets. Now, just in case that is difficult for you, like you don't like working with P and T, we'll just put on the side here X and Y. Okay? So that maybe will help you out. So it says define variables. This looks like we defined them here. Check, check, check. That's done. Write inequalities to represent this problem situation. This is the hardest part, is writing the inequality. So let's go ahead and see if we can do this. How about the first one? Let's do this here. He wants at least 10 screen fixing jobs. Okay, so at least, that means that's going to be less than equal to 10, right? Because he wants at minimum 10 of those. Ideally, in a perfect world, he's going to have more than 10. So let's go ahead and do, he wants phone jobs plus tablet jobs. Okay? So for every phone job he does plus every tablet job he does, he wants that to be greater than equal to 10. Okay? And again, if you like X and Y better, you can put X and Y. It's up to you. And the next one, let's do, it takes him an average of 30 minutes to fix a phone and 45 minutes to fix a tablet. Okay, so let's do 30P plus 45T. 30 minutes to fix a phone screen and 45 minutes to fix a tablet screen. He charges $10 for each, 15. So we're talking about minutes to fix a phone, minutes to fix a tablet, and then it talks about money. Minutes and money right now don't mix, so we're not worrying about that. But if you look here, James has no more than 6 hours available. Minutes is time, and hours is time. So those will probably go together, since this is time as well, right here. Okay? So let's convert the 6 hours to minutes. 6 hours. If 1 hour is 60 minutes, then 60 minutes times 6 hours is what? If you have no idea how to do that, teach you a little trick. You're basically doing 60 times 6, right? So what's 6 times 6? 36, right? And just bring the 0 down. Right here. That's going to be 360 minutes. Okay? So 30p plus 45t, and I think he said that's all he has no more than. So we know 360 is going to go here. 360. And he has no more than that time. So that's going to be less than equal to. Okay? Let me erase this too. So, a system of linear inequalities. I think we did that here. Check. Graph the inequalities. We could do that one at a time. So you know what I'm going to do? I'm going to turn them to x and y because they might get a little too tricky. So I'm just going to turn this to x plus y greater than equal to 10 and 30x plus 45y less than equal to 360. Okay? And I only changed them to x and y so that it looks more familiar, okay? Nothing, no big deal. So let's go ahead and graph these. And again, to graph them, we need to turn them into slope-intercept form. Right now, they're in ax plus by equals c. We need them to be y equals mx plus b. Okay? So, in order to do that, I'm just going to work with the first one here. Now I'll do a different ink. We're just going to subtract x to both sides. And you're going to have y greater than equal to negative x plus 10. And then this other one here, I'm going to work with down here. 30x plus 45y less than equal to 360. We're going to subtract 30x. Just like we did here, we subtracted the x. And I subtract it to the other one too. 30x. And you're going to get 45y less than equal to negative 30x plus 360. Okay? Remember that you can't subtract these because the 360 is just a number and 30x has the variable x in it. So now we want to get y by itself. We're going to divide by 45. And what you do to one side, you do to the other. Those of you that said it. Okay. So we're going to get y less than equal to negative 30 over 45. It's okay if it's a fraction. What number goes into 30 and goes into 45? Think of a clock. 15. 15 goes into 30 how many times? Negative 2. And just add the x. And then 15 goes into 45 how many times? 3. Plus 45. 360 divided by 45? I have no idea. 45. 360. Let's just take a guess. 45 times 2 is 90. I'm going to guess 4. No. I'm going to guess 5. 90, 180. I'm going to guess 6. 6. 6 times 5 is 30. 6 times 4 is 24. Right? 6, 12, 18, 24. Plus 3, 27. subtract 2, 1, 9. So we know the answer is actually not even 6. It's 8. So this is 8. Okay. Those of you that need me to go over this division again, let me know and I'll go over it. No big deal. I can do it for you. You could do it too, though. Okay. So now let's go ahead and take this. And let's move it. And I don't remember how to do it. Oops. There we go. So this is our system that we can graph now. Okay, we haven't even graphed it yet. So let's graph right now. And 8. You guys know I know how to draw straight lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you guys get the idea. So let's go and graph the first one. So starting here, we're going to start at 10. And then we're going to go, remember this is a 1 right here, rise over run. We're going to go down 1 and run 1. And it's a solid line. Okay? Now for the other one, let's use a different color. We use green right here. We're going to start at 8. And we're going to go down 2. 1, 2. Because it's rise over run. Rise over run. We're going down 2. And we're going to run 3. 1, 2, 3. Perfect right there. And that's also a solid because of this, the line under it. Okay. Now, the trickiest part of them all is determining where to shade. Okay. So did we finish our graph? Yep, we graphed it. Last part, identify the solution region. It looks like a lot of math, but we actually did all this before. And so let's go ahead and just test points. I'm going to take all this, copy, paste. Clean it up a little bit. Okay, so let's go ahead and plug in 0, 0 for each one. Oops, that's X. So let's plug in 0, 0. 0 greater than or equal to. -1 times 0 is just 0, plus 10. 0 greater than 10. Is 0 greater than or equal to 10? No, 0 is not greater than or equal to 10. So for the blue equation here, 0, 0 is not a point. So we shade above. Okay, and let's do the green. Let's check the point 0, 0 again. Plug in 0 for x and y. 0 less than or equal to -2/3 times 0 is 0 plus 8. That's why we pick 0, 0, because it's easy. 0 less than equal to 8. Is 0 less than or equal to 8? Yes, it is. That means 0, 0 is a point, and we would shade down here. Oh, but look at this. This little spot right here, there's both colors, right? We have green and blue. And because we have green and blue in that one place, that means that's the solution to our problem here. Identify the solution region. Right there. It's where they both meet. Okay? Any questions on this? Or this is a video, I'm sorry. I guess ask me questions if you have them. And let's see. And again, this is X and Y. And this is our solution there, a little circle part. All right, everyone. Those are all the parts. Thank you.